Merkle trees are a fundamental part of blockchain technology, so let's go through an illustration of how Merkle trees are used in this space. Subscribe to my channel for technical explainers and coding tutorials, and don't forget to give this video a like. I'd really appreciate it. We already know a blockchain is a chain of blocks, and each block contains one to many transactions. A block is actually represented as a hash of all of these transactions. Each transaction is also represented by a hash. So how do we include all of these transaction hashes into the block? Let's consider 8 transactions. We're going to call them T1 all the way to T8. And we are going to hash these transactions, and I'm going to call that H. So each one of these transactions are going to be considered leaves of our tree that we are going to build up. We are going to hash T1 with T2, that's H T1 T2, T3 with T4, that's H T1 T4, T5 with T6, H T5 T6, T7, and T8 is going to be hashed, so then we have H T7 T8. So now we have 4 roots of these leaves, but now we still have 4, but we need to get one single hash. So we're going to continue again. We're going to hash of T1 and T2 and hash of T3 and T4. That will go there. And then we're going to hash the hash of T5 and T6 alongside the hash of T7 and T8. And then we have 2. We do that again. And then finally, we get to the top of the tree where we have a single hash, and this hash is considered the root of the tree. Merkle trees are also called binary hash trees because each node in a tree only ever has 2 leaf nodes. In Bitcoin and other blockchains, Merkle trees are used to hash data more efficiently and make it more secure. The Merkle root, also known as the Merkle tree root, is the topmost hash value in a Merkle tree. We use the Merkle root to summarize and verify the integrity of a set of data, and we can also use it to prove that some data does exist within the Merkle tree. The root can serve as a really compact representation of a large amount of data. So this allows for very efficient verification and confirmation of data integrity inside of the blockchain system. It's not called a tree for no reason, because if you flip it upside down, you see it actually looks like a tree. The root is the root of the tree, and then we have the leaves, which are all the way at the top of the tree. So let's contextualize all of this. When you write smart contracts for Mina Protocol using Snarky.js, you can use a Merkle tree data structure for storing data on the smart contract. Instead of storing the entire data set, which will bloat the smart contract and the blockchain, you can store only the Merkle root on the smart contract. And then if you'd like to verify that some data exists, then you'll need to provide the Merkle witness to the smart contract, which can be used to prove whether the data at that leaf node exists. If you'd like to learn how to code with Merkle trees within smart contracts on the blockchain, then check out this coding tutorial where I show you how to do that on the Mina Protocol by writing a ZK app smart contract. Thanks so much for watching. See you in the next one.